Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Hugo. Hi Hugo, tell us a few words about yourself and about the tool you want to show us.
Hey, Alexi, so great to be here. Thanks for having me. My name's Hugo Bowne-Anderson. My background's in research science, but I work a lot on the full stack of machine learning now, on developer tools and educating people with respect to those tools. So I work at a company called Out of Bounds. I'm head of developer relations there, where we're working on Metaflow, which is an open source Python framework that makes it easy to develop and deploy a whole range of data, ML, and AI apps. It was originally developed by our team at Netflix to support a wide variety of real-world use cases, but it's used across the board now, and that's why we started Out of Bounds as well, in order to meet the demand for this type of software as full stack ML becomes, finds its feet.
Okay. And what is on your screen? What is
fantastic? So I thought to give a brief introduction to, we all know how to do machine learning locally and in notebooks and data science and that type of stuff as scientists. But as we're building production software and starting to think about software engineering principles, there's actually a whole stack of things that we need to take into account. So data scientists love to do modeling, which is at the top of the stack, and thinking about the deployment story and productionization and this type of stuff. They're probably less excited about the compute and data layers, like thinking about how to, access all the different types of data in databases, data engineering, ETL pipelines, configuring Kubernetes clusters. All of these types of things require a significant amount of infrastructure, but the data scientist and ML engineer doesn't necessarily care so much about these things. And it's important to state that, because that's how we think about the stack at Metaflow. We want to allow data scientists, as we'll see, to be able to focus on the top layers of the stack, do the stuff they love best, while having access to all the infrastructural layers below that.
A very nice illustration that shows exactly that. I think I'll use that sometimes, if you don't mind.
Absolutely. Yeah, of course. Appreciate it.
Okay, you want to show a demo, I guess?
I'd love to. And for anyone who wants to code along, what I'd instruct you to do is go to outofbounds.com/sandbox, and we'll include this link below the video. But the intention behind this sandbox is actually, as I said, to do full stack machine learning, you'll need access to Kubernetes clusters and part of the deployment story and orchestrators and all of these types of things, right? And production schedulers. So to get set up with all of that and to be able to demo Metaflow, we've created a sandbox which has access to all of these, which I'll show you in a second. When you go to the sandbox link, it will provision you a sandbox. So you'll click there. And as you love our illustrations, I'll spend 30 seconds going through a little story about, as I've motivated this, what data scientists really do. So their job is to build applications that leverage data, statistics, and machine learning. They need to access data, right? But then they need to access orchestration tools as their workflows become more and more complex. And we need these things to communicate with each other. We need data to go in particular steps, come through other steps, and so on, as we'll see. We'll need to start thinking about versioning, not only code in this case, but versioning code, data, and models as well. And once again, we'll need all these steps to communicate locally. We'll need access to the compute layer, such as a Kubernetes cluster, but there are many others. And once again, we'll need all these to communicate. And we'll need to think about how to deploy these workflows. And today, hopefully, if we make it, I'll show you how to deploy a basic machine learning model from our sandbox using the Argo scheduler, which works very well with Kubernetes. But we'll see we require all these things to communicate. So to that end, I already had that open.
Love the illustration, though.
Well, thank you so much. And it's a function of several things, including our wonderful designer at Out of Bounds and Metaflow, Gaurav, but also our CEO and co-founder, Ville, who I think, Ville Toulos. And we can link to a previous video of his as well. But he loves to draw, so he comes to us with these beautiful illustrations as well. So as you can see here, if you've had any experience with VS Code, we have kind of a browser-based souped up version of VS Code where we have our scripts here. We have some instructions or context setting on the right-hand side. We have terminal here. If you want to explore the sandbox and look at the local file system, you can see everything there. But what we have here is a small table of contents of what we're covering as well. So as we'll see, we're showing how to write Metaflow workflows, then how to think through artifacts and versioning, parallel processing and monitoring, scaling to the cloud, machine learning in action, deploying workflows to production. So hopefully we'll get through most of these as a function of time permitting. But without further ado, what I'm going to do is close that, and what we see here, and we'll get to machine learning in a minute, but I really wanted to give some shorter examples so you can understand the paradigm. We have we go along with the data flow paradigm, so thinking of DAGs, directed acyclic graphs, where data and models and artifacts flow from one step to the next. We are branching, as we'll see in a minute, but here we're working the object-oriented OOP paradigm. We have the step decorator to define steps in our DAGs. We have 3 steps here, which are start, eat, and end. And the one thing we really need to do is tell each step what the next step is. And we do that using self.next to say that eat is the step after start and end is the step after eat. Metaflow doesn't want you to really, we don't want to specify how you write your flows. We have a few basic requirements and constraints, such as you have a start step and an end step. But besides that, it's all yours. So, and to run this flow, what I want to do in the terminal is write Python. So I'm running a Python script. Hello. So I want the path to the file. So it's hello flow.py and run there. Oh, something wacky happened there. It wasn't saved at this point. Great. So what we're seeing now is the flow is running, and we have a bunch of documentation. We'll link to the Metaflow docs as to what all these verbose outputs mean, but it's essentially telling you what's happening in the flow, that a particular task is starting, then it's finished successfully, and so on. And we've automatically updated the right-hand panel here to see the run has completed successfully, and it gives you a bunch more context around that. And it even prints out the DAG of the flow you wrote. And this is all reactive to the code here. So I encourage you to go through and edit this flow and play around with it. In the interest of time, because this is a quick demo, I won't do that. I'll also mention that if you want to run flows quickly, all you need to do is press that run flow button there, and we'll see that in the following. So in the second, I'm going to click run flow and then talk you through the code as it runs. What we're doing here, I want to demonstrate basic branching. Generally, if you want to run independent machine learning training steps in parallel, for example, you'll want to do these in parallel and not sequentially to save resources and as a function of time. And there are several ways to do this in Metaflow, but the way we've done it here is all you need to do is, instead of passing one argument to self.next, you pass 2. So we'll have self.eat and self.drink, and then we'll define those 2 steps. Then we'll require a join step after those 2 as well. And a DAG, of course, a picture is worth thousands of lines of code. What we see here is that the DAG we've created, we have our start step, then we're branching to eat and drink, and then they're joining in join. Now, what's important is to recognize that these did occur in parallel. The eat and drink step, we forced to sleep for 10 seconds each. And we can see that this took 11 seconds. So they did actually happen in parallel. So this is all well and good, but of course, what if we want to start passing variables and models and data between steps? So I'm going to go to the third one. You can do Python name a flow run in the terminal. For time's sake, I'm just going to click run flow there. And what we're seeing is happening here is we're able to version a lot of different things. And the way we do that is we, instead of assigning 5 to the variable X in a step, we assign it to the instance variable self.x, and that makes it available in following steps in the flow and after the fact as well. So this will version everything that you want to save and that you want to introspect afterwards, for example. So what you'll see here, and this is wonderful, if I run this time and time again, all the different states of X will be available for me to introspect in experiment trackers or look through in notebooks or whatever it is after the fact as a function of the run ID. And this is, as I said, there's a lot of verbosity here, but this is 536 is the run ID here. So these are kind of the basics of Metaflow. I do want to talk about scaling out to the cloud. I'm not going to execute this as in the interest of time, but I do want to tell you what is actually happening here. What this allows you to do is, now let me get this right. You saw that we were able to parallelize steps by passing several names to self.next previously. We can also give self.next a list and assign that to the for each construct, which parallelizes over that list. So let's say we had a list of 1,000 different hyperparameters that we wanted to test over, or a grid there. We could then parallelize over that list or grid without having to explicitly tell it every single element there, which is incredibly useful. Now, when we do that, of course, we may want to leverage cloud compute. And once you have a Kubernetes cluster provisioned for you, all you need to do there is assign the at Kubernetes decorator to the step you want to send to the cloud. Now, I can't really emphasize enough how powerful this is, right? Because instead of having to configure your Kubernetes cluster and write all your YAMLs and that type of stuff, you don't need to change any code. Essentially, all you need to do is use the at Kubernetes decorator and send that step to the cloud. You can also, and you can check out our documentation for this, send all steps to cloud resources using command line flags, essentially. Now, I won't run this now because it does take a couple of minutes, as you would expect, and in the interest of time, we'll move on. But I'd encourage everyone to run this and then uncomment this line to really see how you can leverage the cloud computing.
You have Kubernetes in the sandbox, right? So it's actually possible to run it there.
Exactly. And that was really a big part of the intention behind the sandbox, is to teach this type of stuff. I'm very much education forward, and to teach this type of stuff, people require so much setup, right? So that's one of the reasons we did this. So, I mean, not all my colleagues quite agree with this statement, but you can think of our sandboxes, collab for full stack machine learning infrastructure or something along those lines. I think that's a useful mental model. Yeah, so we've set up all of that for you.
Because I remember there used to be Katacoda from O'Reilly, and then it was gone. And
yes,
now,
exactly.
You have this sandbox, so I can't help but wonder if this sandbox is also an open source thing that I can just take a look at how you implemented this and also reuse it, or it's not open source?
It isn't quite open source, no. But we do encourage everyone to play around, because people have done fascinating things with it as well. So jump in and have a look around and let us know how you go.
Yeah, I will definitely try that.
Amazing. So then, thinking more about the production story, what it means to actually, so I'm going to click run flow, and then we're going to talk through it. Thinking about what production can really mean, there are lots of different things we require to productionize machine learning workflows, and we're demonstrating 3 here. The first is freezing library dependencies, which is a very common pain point, right? Validating results as a separate step, and then creating a custom report to visualize the results. So let's just look at how we do that in the code. So that's just one more. What we see is that we use at Conda base at a flow level to define all our dependencies. So I'm using Data Shader, Pandas, PyArrow, and a particular version of NumPy here, right? And what that does is that provisions, using smart containerization of sorts, provisions, all of these packages to be ready for anything I need in my flow. You can also do this at a step level. Let's say you want to send some pretty fierce parallel deep learning training to cloud resources, and you don't necessarily want to import all those chunky packages locally, then you can do that at a step level. On top of that, Metaflow makes sure that your local packages sync properly with whatever's happening on the cloud, because we know that can be a huge pain point. You can also uncomment this line for cloud execution if you'd like. You can see we have our validation step here. And what we're also doing there is we're creating custom cards to visualize our results, which I want to show you now. And so what the terminal outputs, number of things, including the Metaflow UI. So I'm going to go there. And as you can see here, see all the tasks that have been done, and we can actually see a number of them have happened in parallel as well. And I didn't mention this, but the data set that we're looking at is the New York taxi data set, which occurs over several days of the week. And what we've done here is we've parallelized it over those days. We can also see the DAG here, if you're interested in that. Now, under tasks, we can see a variety of things, but what I wanted to point out, we can see all the outputs and all the variables, but what I wanted to point out is here we've visualized a heat map of the data. And this is, millions of data points, right, that we're able to parallelize very quickly using Metaflow, and we're visualizing the taxi trips as over different days of the week. And of course, we can see most activity happening in Midtown Manhattan. You may know this is Central Park here, and a lot of stuff happening downtown. And a lot of action on Saturday, as you'd expect. So going back, there were just a couple more things I wanted to show you. I wanted to, of course, demonstrate. We haven't really done any machine learning yet. We've done about a bunch of data science, but I wanted to run a machine learning flow. And you'll, of course, appreciate that we've seen this figure before. We want data scientists to focus on the top of the stack. But we don't want to be opinionated about what tools you use, right? Because if you use scikit-learn, we want you to be able to use scikit-learn. If you use PyTorch or TensorFlow or XGBoost, we want you to be able to use those tools, right? And we do support, as we've written here, many use cases from NLP to computer vision to operations research. And so we're showing here basically training and testing a model of taxi fare regression based on the NYC taxi data set using scikit-learn. Okay, and you can go through the code. You can see we've featureized our data. We split into train and test, figure out what features we want, and so on. And we build a random forest here. And as I'm running it, you can see our start step, includes 1 million points. Great. Then our modeling has started and finished successfully. Now we're doing some evaluation. And what I'll actually show you in our Metaflow UI is the report we're creating actually will visualize model performance, so predicted versus the known fare on the regression task. And you can see here we've printed out the root mean squared error. So this should finish in a couple of seconds. I'm wondering, pardon me, if there's anything else I want to say about this code. No, I think that's pretty much it. You can see our evaluation step has ended and we're just creating the report. So that should take.
I noticed that you put imports inside the tasks, inside the methods. That's intentional, right? Because like every single step requires a different set of libraries, different set of imports. That's why you put imports inside these methods, right?
Exactly. So that's exactly right. So yeah, when we don't require it, to make it as lightweight as possible, we don't do the imports there. Exactly.
Okay, cool.
And so once we go back to our UI, I'll maximize that again, and I'll take us to the tasks, and we'll have a look at the report I created that I mentioned, and we'll see exactly. So you can insert any data visualization, your data visualization package of choice, whether it be data shader, Altair, Matplotlib, Plotly. You can create figures in here. So you can see we have correct versus predicted fair there for our machine learning workflow. So to wrap up, I know we're pushing against the boundaries of time here. To wrap up, I'd like to just tell you a bit about the productionization story and deploying workflows to production. So I'm going to click deploy flow. And what this actually does is what we want to do is make sure that when I close my laptop at the end of the day and go and, have dinner, that these workflows are still running independent of my work, independent of my laptop. So that's why we want to deploy them. And essentially, we use a scheduler called Argo. And so we've seen how we develop, how we scale to the cloud, and now we're seeing the deployment story. Metaflow integrates with a lot of different production schedulers. We're using one called Argo here, and which works very well with Kubernetes. And what we've done here is we've created the workflow, but we haven't triggered it. So this is the URL down here for the Argo workflow, and I'll make this as large as possible. This is all the information around the workflow, the deployment here. But now I actually want to trigger it to actually get it up and running. So let me show you how I do that in the next section, which is all about reactive machine learning. So you may want to trigger a production run or a model to deploy once data is available, or once data is updated on S3, for example, in Parquet, or once you may want to trigger your inference flow once your training flow is done. There are lots of different things you may want to do. So essentially, we have a whole variety of events which make you want to trigger your flows. And this is a very new feature of Metaflow, actually, the ability to use essentially arbitrary events to trigger machine learning runs. And the event I'm going to use in here is essentially execution of this notebook. You can do it a number of other ways, as I just said, but for demonstration purposes. So the flow I just created has now been triggered, and now I want to see the run in Argo. And look, previously it said running workflows was 0. Now it's 1. And so this is the workflow in question, and we'll actually see that it's been triggered. It's started. It may take a couple of minutes to run, so we're not going to wait for that now. But what I will show you is one I prepared earlier, which we can see it was triggered, it started, and it ended. So these are deployed workflows now that you can do from within the Metaflow sandbox with that type of ease. So I appreciate we went slightly over time, but I hope that was okay. And I'm really excited to answer any questions.
For showing all that. That's pretty impressive. Really, like, you put so much effort there. But I'm wondering how many people are actually working on this, because it looks like there is a large team behind everything you showed us.
Yeah, so on Metaflow, actually, we've had, if you look at the GitHub repository, we've had around 70, 80 public individual contributors. So Netflix has a sizable ML infrastructure team, a lot of whom contribute to Metaflow, but everyone pretty much at Out of Bounds contributes, and we're around 15 people. And then companies like Moneyline, Zillow, 23andMe, a bunch of others who run their businesses on Metaflow have teams contributing to core Metaflow as well. But the sandbox I've just shown you really comes from the Out of Bounds team. And we have, 15 headcount generally, but it's a smaller subset who really push out all these wonderful features on the sandbox.
Yeah, that's pretty impressive. And if anyone wants to contribute, how do they go about that?
So the best place to get in touch with us is on our community Slack, and that's slack.outofbounds.co, and we can put that link in the show notes. And
co, not com, right?
yeah, exactly. And it's worth saying a bit more about how we think about contributions. We love contribution. We love talking with people who use Metaflow as much as possible. In contrast to some other OSS projects, we mainly encourage people to contribute by using Metaflow and giving feedback, which hundreds of people have done. And then we incorporate the changes into Metaflow instead of accepting all PRs lightly. The way we think about it is that's kind of a crucial part of what we do, is we really want to maintain a strong guarantee of stability and backwards compatibility, as well as an excellent product experience. But please come and join us on Slack, and you'll see we've got now thousands of data scientists daily asking questions about Metaflow, full stack machine learning. Wonderful to see them answering each other's questions as well, and seeing what people come up with.
Okay, yeah. And what are your plans for the future? Like, is there anything you are working on right now that you can share with us?
Yeah, I'll say a few things. I think this new feature I've just showed you, the event triggering, is actually an incredibly major feature that will be a core building block in many future features, such as those related to data. I mean, you can imagine, having events in data warehouses, in Snowflake, wherever it may be, and that needing to interact with your deployment of your machine learning workflows. So we've got a huge number of things to come on the data front. And definitely we talk about all of these on Slack as well. So feel free to join there or look at our blog whenever you like. And you can find that on outofbounds.com. The other thing, I know it's kind of a topic du jour in a lot of ways, but we're actively working on a lot of large language model and GPU related topics. So we actually have a new GPU profile card. I showed you some of the cards you can generate using Metaflow. We have one which allows you really to introspect what's happening with your GPUs, which is provides a lot of utility. But in that space, so LLM and GPUs, we're doing a lot of exciting stuff as well. And check out our blog and what we're talking about on Slack for that.
Cool. Last question. Do you have any advice to anyone who is watching this? Yeah, I think for those data scientists and MLEs, we try to encourage you to do what you love. And if that's the science and the modeling and running experiments, very much do that, and find tools, find software, find people, colleagues, organizations that allow you to do that. But don't be shy in kind of spreading your wings and trying to learn as much about software engineering best practices and principles as possible. Advice is, yeah, I think there's just so much to learn in this space when wanting to do full stack machine learning. So as you've gathered, hopefully, we want to create software and education which allows data scientists and machine learning engineers to focus on what they do best: the modeling, the experiments, the deployment, these types of things. So definitely find the tools, find the people, find the organizations and workplaces that allow you to flourish with what you want to do and what your skill sets are. But I'd also encourage you in the same breath to spread your wings and kind of get a bit dangerous at points. And if you're not a professional software engineer, that doesn't mean you can't learn more about software engineering best practices. And I definitely don't think any data scientist should need to know about Kubernetes, right? Or know that much about Kubernetes. But if you have an interest in learning about Kubernetes, what a wonderful thing to do for your to have another differentiator in your toolkit and for your skill set as well. So there's a trade-off there with respect to doing the work you love and learning new things. But in a space that's growing so quickly, I'd encourage you to learn as much as possible. Adding Kubernetes to your skill set will definitely help. That's from what I see. It's definitely a good idea. Okay, Hugo, thanks a lot for doing the demo. Amazing demo. Thanks for the advice. And yeah, it's a pleasure to have you here. So maybe when you have something else that you want to demo, we'll be happy to have you again.
Absolutely. And I really appreciate the opportunity to bring the stuff we're working on to your community. So thanks, Alexei, and the whole community as well.